and Wednesday will be our Chapter 5 test. And then we'll start reviewing for our final exam. So really today is kind of like the last set of like regular notes for semester 1. So we've reached the end. Okay. And we're going to finish with inverses. Inverses are two functions that are related to each other, but they're special functions because they undo each other. Okay. So that's what we're going to talk about first. Can I get the slide to change? Inverses are a pair of functions that undo each other. You have probably heard the word inverse before. So as you're writing things down, if you finish early, maybe think about when you've heard the word inverse and how it might be related. There's two steps to finding an inverse. One step is switch x and y, and a second step is solve for y. That's it. That's all you have to do. Because you're switching x and y, you are doing two other things, and those are the things that are listed right below that statement. By taking all of your x's and making them y's, you've just made your domain your range. Because domain is always x and range is always y's. And then vice versa, because you took all your y's, which were your range, and turned them into x's, they became your domain. So domain and range is always switched for an inverse. Okay. Also, when you think about it graphically or visually on a graph, inverses are reflections over the line y equals x. So if I drew a picture of a graph, and there's a line, I'll call it f of x, and I wanted to know where its inverse was, the inverse of f of x is going to be the line that gets reflected over the line y equals x. Ooh, that was probably not my smartest line draw. Change it. How about this line? I'll call f of x. And so all I would do is I would take this line and I would reflect it over the line y equals x. So like this point that's on that line, they would share, but then like this point would reflect over here. This point, remember how you would reflect in geometry, you'd measure so it's the same distance? That's probably a little too far. It's looking away. But it's like if I would fold the paper right there, they would map onto each other. Okay. So this would be its inverse function. And that's because you switched x and y. So if there was one big takeaway from today's notes, it's that you should switch x and y to make an inverse. That's always. Whether you're looking at an equation, you're looking at a table, you're looking at a graph, switch x and y, reflect it over the line y equals x, and you have an inverse. Okay. So we want to find inverses from equations. Let me give you this equation. F of x equals 1/3 x minus 2. F of x equals 1/3 x minus 2. Now the directions to find the inverse are to switch x and y. And some people might look at that equation and say, how can I switch x and y if I don't even have a y? What part of that equation is y? What's equal to y in f of x equals 1/3 x minus 2? Well, what's y? F of x. F of x is just a fancy way to write y. So all I'm asking in that question is, I wouldn't use f of x. If I'm given something in function notation, I will rewrite that because that's just a fancy way to write y. So first, I'm just rewriting the same problem so that it's not in function notation. So now I have an x and I have a y. I really don't want to mess with it when it's f of x. That's too much. Okay. So then I think about what I need to do in order to create an inverse. Switch x and y. Where I see y, write x. Where I see x, write y. That's all you have to do. So this becomes x equals 1/3 times y minus 2. I'm starting to write the inverse. A common mistake in the very beginning for some people is like when you move that x, some people might want to put like a 1/3 x because you think the 1/3 is part of that, but you really only are changing the letters. None of the numbers, none of the signs will change until you solve for y. Now, we don't want to leave our inverse like this because we like our equations instead of x equals to be y equals. So we're going to concentrate on what we can do to solve for y. So Justin, tell me what's one thing you would do to get this y all by itself?
Put something on the other side.
Put what on the other side?
Something.
Yes, put something on the other side. Which number will you move first?
-2.
Yeah. To move -2 to the other side, we are going to add 2 both sides. Perfect. So x plus 2 equals 1/3 y. Now we still need to get y all by itself. What do you think you might do to move the 1/3? Here, you say multiply it by the inverse or the reciprocal. Yeah, when you flip it, yeah, multiply both sides by 3. Now, on this side, the left side, we really want to multiply the whole side by 3. What do I use to say all of something? Parentheses. So I would probably then just throw in a group of parentheses real quick and then distribute. But that will help me remember to distribute through the equation. So here I can distribute my 3 and I'll have y equals 3x plus 6. There's my inverse. Now you can name that with a different letter if you want. I'll accept it as y equals. You could, since we already have f of x, you could call it g of x if you wanted to. So you can give it a different name. I do want to show you a notation that you might see like in the book. To say it's the inverse of the function f, you can write it in a special function notation. You start with f, but we already have a function f, so to say inverse, we put what looks like a -1 exponent on the f. It doesn't mean anything mathematically, because it's really just a fancy way to write y, but this just would tell you this is talking about f inverse. So it's not the original function, it's the inverse function. Again, I don't need you to write it with the F inverse notation, but just don't be scared if you see F inverse notation sometimes. Okay, you try this one. Find the inverse of f of x equals 3x minus 1, and I'll come walk around and see what you're doing. Great work! I notice a lot of people taking f of x and writing y equals 3x minus 1. Again, don't forget that's not actually switching the x and y, so you still have to do that step, which will give us x equals 3y minus 1. So here we're starting to write the inverse. This part, the first step there, is still the original problem. I think most people were okay with saying they were going to add 1 to both sides. And then some of us are a little hesitant right here, like, what should we do with this if we have 3y? Well, you still have to get y totally all by itself. If it's being multiplied by 3, then you could divide both sides by 3. Okay? And that would be fine here. Okay? If you divide by 3, this whole side gets divided by 3. I'll accept an answer of x plus 1 over 3. Okay, that's fine. Some of you may simplify that, and you may write that as y equals, and you would do like 1/3 x plus 1/3. So it looks more like slope-intercept form. It's possible that like an algebra teacher taught you to do that, because it's really just 1 over 3x plus 1 over 3. But either one of those is fine. I would guess most people would leave it like this. Questions there? Okay, now we're in chapter 5, correct? Which is radicals and rational exponents. No, suspense. So see if you could write the inverse for f of x equals x plus 1 cubed plus, minus 2. Try to apply some of your knowledge from chapter 5. And it's okay if sometimes you start something and then you get a little bit stuck. Okay, that's bound to happen. Y equals the quantity x plus 1 cubed minus 2. I would start by switching my x and y, because that's like the most important part of making the inverse, correct? That at some point you have to switch x and y. Now, your job is to try to get y all by itself. A lot of people see that y is trapped inside that group of parentheses as being cubed. And so some people who are focused on my hint about chapter 5 wanted to cube root right away. I think my only argument would be you really only want to cube root the y plus 1 cubed, correct? So in order to only cube root that, you need to move anything else to the other side first. So that 2 that's not being cubed, add it to both sides right away. Okay. And I saw many of us were thinking somewhere along those lines. So we say x plus 2 equals y plus 1 cubed. And then there's that moment where you're thinking, oh, am I going to have to do y plus 1 times y plus 1 times y plus 1? That sounds terrible. But we actually don't want to do any kind of multiplication. We want to undo things. So if this is being cubed, what would undo a cube? A cube root. So that's where we're bringing in our chapter 5 knowledge. To get rid of a cube root both sides. And so I end up with something that looks like the cube root of x plus 2 equals y plus 1. And my final step is subtract that 1. Now that one will get subtracted outside of the cube root. So I won't be able to combine the terms of 2 and 1. And that's okay. My final answer. So the important part is switch x and y, of course. And then I would also say, in a problem like that where there's multiple things that you have to do, take it easy, go slow, one thing at a time, and focus really on, like, if there wasn't two variables, if there was a number, you're doing the same steps to solving. So very similar to what we did in section 5.4. There's one other example here that we want to do with finding an inverse, and I want to show it to you because it looks a little funny at first. Okay, so when you're looking at this, I want you to find the inverse of f of x equals 16x squared when x is greater than or equal to 0. And so it's that extra piece, the x is greater than or equal to 0, that will kind of scare some people at first. But you don't have to be scared. It really doesn't have a big part in actually finding the inverse. It's more of like what your answer is at the end of your inverse. Okay, so could you tell me, if we were just going to make a graph of 16x squared, what shape would that be? I don't know. What shapes are x squareds? Kylie's drawing a U. Aren't they all parabolas, quadratics? Okay, so this would have been, I'm thinking about just 16x squared. 16x squared would be some kind of really skinny parabola because of the 16. And then this, x is greater than or equal to 0, is saying don't include the whole parabola, only include the side that is greater than or equal to 0 for x's. So x is 0 at the origin, correct? And then it's greater than 0 on the right side. So it's saying, just imagine it's that one arm of the parabola. Instead of the whole thing, focus only on the right side. We're going to find the inverse for the right side of the parabola. Now, why are we saying that? Think about how you'll solve if you have something that's being squared. At some point, you're going to have to take the square root. And when we solve equations, what do we normally add when we take a square root? A plus or minus. When we put this restriction here, it means don't include the plus or minus. If it's x is greater than or equal to 0, the inverse is positive. If it's x is less than or equal to 0, the inverse is negative. So instead of putting the plus or minus, you'll only put one of the signs depending on what that little greater than or equals says. So again, it doesn't really play into the actual calculation of your inverse. Okay, we would do our inverse as normal with just y equals 16x squared. So I switch x and y. X equals 16y squared. What would I do to solve for y? What numbers do I need to move to the other side? Got to move the 16, so I'm going to divide both sides by 16. That's x over 16 equals y squared. Then I'm going to have to square root both sides to get y all by itself. So I'm going to come up with y equals the square root of x over 16. Since this was greater than or equal to 0, I just have it be positive. I don't put a plus or minus. If it was x is less than or equal to 0, I would put a negative in the front of it. That's all that says. What can you do with the square root of x over 16? That can simplify. What is that?
So
X over 4? Is that what you were going to say, Damon?
yeah.
X over 4? Oh, the square root of x over 4. So think about it like it's the square root of x over the square root of 16. You could break it up, which the square root of 16 is 4, but you still have a square root in your answer. So y equals the square root of x over over 4. So be careful there. If it was x squared, we'd get just x, but since it's x, it stays what it is. Okay, I'm going to give you your homework assignment, and you will have, whoa, a lot of time to work. Okay.